previous lecture we did instrument level volatility targeting, or position level volatility targeting, and then one hierarchy above each position would be a strategy. So that's the strategy level volatility targeting, and one hierarchy above the strategy would be the entire portfolio. So we'll be looking at the strategy level volatility targeting. There are also a few minor mistakes because we're really explaining things as we go along. And sometimes I write things and I don't really know. I don't really pay attention to what I'm saying. So I made a mistake here. So this, of course, should be 1 over n, and this should also be 1 over n. So it's not critical to the code, but because we just do Gauss standard deviation, but mathematically speaking, this is the sample estimate for this population statistic. So let's go back to the code, but this time what we're going to do is the volatility targeting for the strategy. So we're going to be trading our portfolio. We start with $10,000, and you can imagine, it's going to go up and it's going to go down and things like that. And of course, we can compute the volatility of the historical period, right? And remember, this is our target volatility. So we set this to annualized target volatility to 20%. So if our historical volatility is lesser than our target, then clearly we need to be scaling all of our positions by some level. That is, so let's say this is realized volatility by this amount. We want to scale our positions going forward to be larger. On the other hand, of course, if the realized volatility is larger than the target volatility, then so in this case it's greater than 1, and in this scenario it will be lesser than 1, right? So going forward, we will scale our positions to make sure that our target volatility and our realized volatility are constantly in tandem. And of course, these values will be dynamic and moving up and down in real time, which means that we will accordingly scale the ratio. Now, we're going to do this with 2 different scalars. So if this confuses you later, what we're going to be doing is we'll be computing the strategy volatility using what is known as a exponentially weighted moving average. So we'll call this UMA, right? So you can refer back to this formula. So let's take this formula and paste it over here. So one thing you should know about return is that the expected return is going to be, this is going to be very close to 0, right? This is almost 0. So we can sort of say that signal return is equals to the square root of the expectation of r squared, because this is about 0, and then our estimates will then be equals to the expected value of this. If we take a simple moving average, then we'll just do 1 over n, and then we'll do ri squared, right? So this is maybe the historical look back, and we'll do this. But instead of doing 1 over n, we're going to do weighted moving average. So what we're going to do is we will take 0.96 of the previous return t minus 1 plus 0.04 of return t. And what this does, so okay, we're going to update our variance statistic like this, and this will be our estimate of the variance of the strategy. Right, so what this does is today's return is going to get a weighting of 0.04, and the previous day's weighting is going to get 0.96 times 0.04, 0.096 squared times 0.04. And you can see that the historical returns, the further away it is in history, the lesser weight we give to the entry. And we're going to compute a moving average of that to give our estimate for the return sample statistic. And to give our return sample statistic, which is our estimate for the volatility. And forgive me if I'm making some mistakes in the speech, because, and I'm not reading off the script, I'm doing these things and I'm saying things off the top of my head. So here and there I will say some incorrect, imprecise technical terms, and if those are problematic, you shouldn't put too much weight onto what I'm saying. So it'll be a lot clearer once we go ahead and write the code. Now we're going to use this thing to scale each of our positions. So let's go ahead and instantiate this here. So sub.umus, sub.ustrats. Okay, sub.strat scalar equals to that. And let's say our default strategy scalar is equals to 2. But if we are past the first day, then we want to actively compute a new scalar depending on the historical realized volatility for our strategy. So scalar. So this thing should take in our target vol, which is sub.preferred vol. It should pass in our exponentially weighted moving averages. And then it should take in our previously used strategy scalars. So we need to implement this function. So let's put that over here. Def get strat scalar, target vol, use strats, and this is the implementation. So what is our implementation going to be? Well, first we want to annualize the realized volatility. Okay, so this is going to be the last annualized volatility is going to be inside this list, and want to multiply, the last annualized variance, which is the square of the volatility, is going to be maintained inside this list. So we want to take the square root of that, multiply by the square root of 253, and this will be the annualized realized volatility. And as we said, we're going to take the target volatility divided by the annualized realized volatility multiplied by the current strategy scalar that we are already implementing. The reason why we have to multiply by this is because this annualized realized volatility is a result of using this strategy scalar. So we're saying that based on the strategy scalar that we have already been implementing to arrive at this realized volatility, how much do we need to scale our strategy scalar going forward? So I hope that makes sense, right? Let me repeat that again. This is the current strategy scalar we are using to obtain this annualized realized volatility. So in order to scale this value, in order to adjust this value to hit our target volatility, we need to multiply by this scalar. So this is the strategy scalar. Okay. So we would like to maintain this inside here. These are the strategy scalars. In order to maintain a exponentially weighted moving average, we're going to do 0.06 multiplied by capital return square plus 0.94 times sub-umus. So we don't update the moving average if the previous day was not even a trading day. Otherwise, we will take the exponentially weighted moving average. So here we do strat scalar okay. So that is interesting. We will only do this from the first day onwards. So let's instantiate this with 0.01 and 1. So the default exponentially weighted moving strategy scalar will be 1, and it will be 0.01 for the capital return. So you get the idea here, right? So we're constantly maintaining a moving average of the strategy scalar as well as the realized variance of the portfolio. And we only update it if the return is non-zero. If the return is indicates that we have active positions and there was trading day. Otherwise, we will not update it, and then we will keep updating this strategy scalar. So now that we have this strategy scalar, we want to scale each of our individual position, and that was the purpose of the whole thing. which means that inside this position, we want to multiply it by the strategy scalar. And now our portfolio volatility should be fairly interesting to see. So let's move this up and see whether we can hit our target volatility. Okay, so let's try this. And the return fall, and we will do this as well as this. Right. So hopefully we hit our target volatility. We'll see whether this works. Gas scalar. Okay, we need to put on cell here. Let's try it again. So far, I mean, I think this is probably the most difficult concept so far, mathematically speaking, but it's still not that difficult. So I hope that you can understand what we're doing here, because volatility targeting will be the core of our risk management going forward, and also happens to be the industry standard when it comes to risk management, right? So let's just wait for our code to complete. And if this works, we've basically implemented what is known as strategy volatility targeting and instrument volatility targeting. So inside the next lecture, we will explore, okay, so this is our strategy capital, and we hit our target volatility, right? So that's good. We hit our target volatility, and in annualized terms, we are at 20% volatility, which is very good. But inside the next lecture, we will explain more on portfolio level volatility targeting and how to combine the positions from the 3 different strategies that we have. And this will basically give us a multi-strategy portfolio. So now we're working with portfolios instead of strategies going forward. And we'll see exactly how to do that in the next lecture.